the review that we started yesterday. And then, when I'm done with that review, then I'll take whatever questions you have, okay? But we only have a couple more problems to do on this review. So, here we go, number 10. Solve graphically. Now, obviously, the calculator is going to do everything. So, what do you need to show? Well, you need to show me what you see when you graph this. And you need to tell me how you set your window up to see what you saw. Okay? So, I always just zoom 6 to get started, because that gives me just the regular old windows, the standard window. If you don't want to do that, that's okay, but then you'll manually adjust it. So I zoom 6 to get started. Now I'm going to type in my equation, remembering that x cubed, I have to use that button. Get x cubed plus 4x squared minus 6x plus 1. Now, I am looking for where it equals 0. So what I see on my calculator, and I'm going from negative 10 to 10 and negative 10 to 10. Those are my windows, standard windows. I see a picture that looks like this. You should, if you use the same window I did, you should see something that looks like that. So zoom 6, just to get the window, this window, and then this is what I see. Now, that doesn't have to be what you see when you're doing this on your own. What you do have to be able to see are these 3 points, because those are the answers, right? So I need to find them. So I'm going to start with this one right here. It doesn't matter which one you start with. I just always go left to right. I'm going to start right here. So second calc 0. And then I have to move my cursor so it's on the left of, oops, I think I wrote it down exactly. So it's on the left of my hand. So in other words, it's going to be down here somewhere. And press enter. Then I have to move it so it's up here somewhere to the right. And then I got to put it in between there. And hopefully you got right here, this one is negative 5.193. That's what you're shooting for. And then we'll repeat the process for that guy right there. So second calc 0. Now I need my here. Now this is the point I'm looking for. So this is now going to be left bound, and down here is going to be right bound. Be careful. You got to be in between your points here. So it's going to be left on this side, right on this side. So here we go. Using my arrows. My left. Right. And for this guy right here, I got x equals 0.193. And then I'll do this one. So for this one, left will be over here and right will be over here. So second calc 0. Left. Right. Oh, I got 1. Anybody else get 1 for that one? Perfect. So the answer is x equals those 3 numbers. that is where the equation equals 0. Those are the zeros. Now, B is the same sort of, but it's an inequality. Okay? So who has an idea about how we would do this? We had a couple different strategies. Jake, what do you want to do?
You want to plug in the x squared minus 5x on the y1, and then you want to plug in y7 on the y2.
So Jake is going to do this with intersections, which is absolutely fantastic. I'm going to leave my window the same. For now, I think that'll work. I'll find out in a minute. But for now, that's what I'm doing with my window. I'm going to type in my two equations, just like Jake said. Press graph. Oh yeah. So again, you're showing me what you see. And what you see is a parabola and a line coming across it like that. So what do I need to figure out? I need to figure out where they cross. Now, those two will not be the final answer, but they're part of the final answer. I need those 2 points. So, second calc intersect, and your left bound, this is a point, so your left bound has to be over here on the left side, and then you're going to be on the right side of whatever curve you got. It doesn't matter, just be on the left and the right. So I got negative 1.140. Second calc intersect again, and this time I got 6.140. How does that sound, everybody? Okay? Now, in this problem, I would be done. In an equals problem, I'm done. But I'm not done here because I want the parabola to be higher than the line? Greater than, higher than, yep. So that's this part of the picture and this part of the picture. That's where the parabola is bigger than the line? So negative infinity to negative, I can't read it, 1.140. And that one would be a bracket. Infinities are never. Or 6.140. Infinity. Okay, does everybody see the difference between how you answer this one and how you answer that one? An equals problem has x equals as the answer.
The answer was domain.
What?
The answer was domain.
No, in this problem, the domain is actually going to be all real numbers because it's not a word problem, so there's no restrictions on it. So the answer is where parabola is higher than line. Okay, so that's these two sections. Greater than means above. Okay, so on these graphing problems, expectations are you do what we have done here. Is everybody okay with that? All right, number 12. I will give you the formula. You do not have to memorize it. The general formula. You will need to plug in your numbers. But the general formula is this. So what is it for our problem? The initial velocity is 38. And the initial height is 10. And I'm looking for my height, right?
Yep.
So A says write the equation, there it is. Now, I put H here, you can leave S of T. If you'd rather use the function form, that's fine, doesn't matter. Just make sure you have these numbers plugged in. What is the height after 1/2 second?
So you plug in 1/2.
Plug in 1/2, so I'm gonna plug in 1/2. And if I do it by hand, you're all gonna be sitting there with a calculator, so, but if you're doing it by hand, make sure you square first, PEMDAS. If you're doing it on the calculator, you can just type that in. I got 25. Jake,
Could you also plug it in on the graph?
you
And
should.
then,
Yep, I think that's gonna take longer, but yeah. Yep. All right, are we okay with that, folks? Remember, you gotta show your work though, so if you're doing it graphically, make sure you're showing what you did graphically. When is the ball gonna be on the ground?
that's your,
When the height is 0. So that equation is going to look like this. So if you graphed that on your calculator, you would again, that picture is gonna look like this because the ball came off the building here. You would be looking for that point right there, right? You could also do this algebraically using the quadratic formula, okay? So I'm gonna go ahead and do that because we haven't done one of those yet today. You guys that wanna graph, that's okay. Hopefully we end up with the same answer. So T equals -38.
Wait, you did it.
You can absolutely divide everything by -2.
Yeah.
Yeah, won't hurt a thing. Makes your numbers smaller. You absolutely can do that, Elijah, so feel free. And you'll see we get the same answer. Alright. I don't know, I got -0.239.
2.614.
And I got 2.614. What about this guy? We don't want negative time, right? That's before the ball is even thrown. It's back here, right, before we climb up on the building. So we throw that one out. So the answer is 2.614 seconds. You guys have graphed it. We should match. Exactly. I mean, to that many decimal places. All right. When is the ball higher than 12 feet? So I want it to be higher than 12 feet. So what is your thought on that, Sam?
I put it in the graph and I put y equals like the original equation.
Okay.
And then I put y2 equals 12. And then found the intersections, which is 0.0539 and 2.321,
Okay.
which you put in an interval and no brackets because it's higher
Than?
it's not.
Okay. Now,
You can do
flew
it.
through that. Are y'all keeping up? He said, I'm gonna graph two things. I'm gonna graph my ball, there it is, and there's 12. So, obviously, the ball crosses 12 twice. So he did second intersect, or he did second calc intersect. And what did you say they were again? This was
0.0539.
0.54, and this one was.
2.321.
So those are the places, according to Sam, where the ball is exactly 12 high. And again, we got that by second calc intersect. Now the question says, I need the ball to be higher than 12. So that would be this part, right? And since it's higher than 12, he said no brackets, because higher than 12 means they have to be above those points, and that would be your answer. Now, I did not type that in, so I'm taking his word for it that those are right. Okay, and just when you thought you're done, you're not, because over on the first page is number 11. I don't know if you noticed we skipped from 10 to 12, because 11 is over here. Gotta squeeze in as much as we can. All right, so we got some data here. Got the years, imports and billions. Use the data from 1999 and 2002 to write a linear equation for the data. Write a linear equation, so let's just stop right there. What do we need to write a linear equation? Slope. So slope will be 55.1 minus 53.2 over 2002 minus 1999. Is that okay with everyone? So, what is that? 1.9 over 3. Okay, now listen. We don't like fractions and decimals mixed. Like we have a decimal inside a fraction. So the easiest thing to do is multiply the top and the bottom by 10. So now I have a clean fraction. Y minus, I don't care, 53.2 equals 19/30ths, x minus 1999. Is that okay with you? Is that a linear equation? What form? It is a linear equation, but it is in point slope form. These directions don't tell me, so point slope is fine. Let's go ahead and put it in slope intercept because it's going to help me in the next part of the problem anyway. So what do I need to do? Y minus 53.2 equals 19/30 x minus, I'm distributing, so 1999 times 19, 37981 over 30, because I'm multiplying that guy by 30. Now I need to add this over, right? Let's not get all crazy here. This is easy, got a calculator. So I'm gonna take my negative 37981 divided by 30. And I'm gonna add 53.2. Did you get a decimal? Since we got a fraction here, let's go ahead, just hit math, your math button. First option is frac, hit enter, and it will change it into a nice little fraction for you. So, if you have a decimal and you want a fraction, just press math, enter. Now, last thing, and then you're gonna go to lunch. Find the imports in 2020. Put 2020 in for, now remember, in your ordered pairs, these were the year, and these were the money. So where does 2020 go?
X.
X, it's a year. It's a year. So I'm just gonna put 2020 right here. So 19 divided by 30 times 2020, that was the year, yeah. And then minus 7277 divided by 6. Oh my, did you get 66.5?
Sure did.
Wow, who would have thought that would have happened? Got it? Alright, wait, too early, I can't send you yet. Here's what I want everybody to do. Find a question you're gonna ask when we come back from lunch. So either look at a homework quiz, the other review sheet, remember I gave you an unfocused review. So everybody finds one question, and then we're gonna answer after lunch.